Hello, today I'll be talking about Lab 1, charge tapes, in which we attempt to quantify the amount of charge on a single piece of tape. The objective of this lab was to make two pieces of charge tape and then set up an experiment to determine the charge of one of those pieces of tape. Down below you can see a few of the important equations and constants which we'll be dealing with later in this lab video. For the setup of this lab, I made two pieces of charge tape by quickly ripping a piece of tape off of the base tape. This piece of tape was determined to be positively charged because when it was placed in contact with a pin known to be negatively charged, it was attracted to the pin. Two assumptions we made in the lab are that the two tapes are assumed to have the same magnitude of charge, and that each tape can be treated like a point charge in which all charge found on the tape is concentrated at the center of the tape. For the actual lab, I placed tape B on a stack of books and then measured the distance traveled by tape B when it was repelled by tape A. In the actual experiment, tape B had a length of 0.193 meters and a width of 0.019 meters. We then used a few assumptions to determine that tape B has a mass of about 0.000193 kilograms. During the actual experiment, we determined that tape B traveled 0.016 meters after being repelled by tape A. Also important to this experiment is Newton's third law, which implies that the net force when tape B is floating is zero, meaning that the electric force in tape B is equal to the negative gravitational force felt by tape B. By performing a few calculations, we found the force on the tape due to gravity to be negative 0.001891 newtons. Therefore, the force on the tape due to the electric field from tape A is 0.001891 newtons. Finally, using these previous calculations, we were able to determine that the charge of tape B is 7.33484 times 10 to the negative 9 coulombs. On this slide, I performed more calculations related to the lab. The first calculation was related to calculating the number of electrons lost by tape B, and I did this by dividing the overall charge of tape B by the charge of a single electron to find that tape B lost 4.58427 times 10 to the 10 electrons. I also calculated the number of atoms found on tape B by dividing the area of tape B by the area of an atom. And after doing this, I found that tape B has roughly 3.667 times 10 to the 17 atoms. I also calculated the ratio of the electrons lost by tape B to the atoms found on tape B, and found this ratio to be 1.25014 times 10 to the negative 7 electrons to 1 atom. On this slide, you can see my glow script code. Up top, I have my constants which I used within my calculations. Then down below, I have a section for forces in which I calculated the force due to gravity and the electrical force acting on tape B. Further down is where I produced my objects. For tape A, I produced a blue sphere at location 000, and for tape B, I produced another blue sphere slightly higher up. I also produced two arrows, one to represent the force due to gravity and another to represent the electrical force. And finally, I also calculated the Q value of tape B in glow script. In this slide, you can see the result of my glow script code. The glow script model shows two particles, tape A and tape B, and the two forces acting on tape B. The red arrow represents the electrical force acting on tape B, while the yellow arrow represents the gravitational force. Then down below you can see the values of the gravitational force, electric force, and the magnitude of the charge. These values are the same as what I calculated previously, further confirming my results. To summarize, we determined the charge of tape B to be 7.33484 times 10 to the negative 9 coulombs. We were also asked what would happen if electrons had positive charges and protons had negative charges. Although this would change the charge of the actual tape, this wouldn't change anything about the physical system because like charges would still repel each other and opposite charges would still attract one another. Therefore, the tape A would still repel tape B and tape B would thus still float. During this lab, it is important to avoid handling the tapes as much as possible because these charged tapes can lose their charge when they come in contact with neutral objects such as your hand. This is because your hand might have some free negative charge, which it might pass on and thus diminish the overall positive charge of the tape.